Hi, everybody. Let me adjust the sound. And this is a review recording for the final exam. When I sent you the lab material, I didn't include suggestive slides. That was an error on my part. I'm not going to add to it. That's not necessary for me to add additional work for you. You have enough to do. So I do want to, uh, and let me just get to where that particular area is. But I do want to go over the exam, and I want to remind you that digestive is on it. And in fact, we'll start reviewing it. Remember, the alimentary canal is basically just a continuous tube that's there, and all the way it has shaped and changed over time. Basically, it's still a hollow tube that goes through you effectively. And that means so everything that is not part of that tube, so effectively the mouth, you want to consider that starting point. The esophagus, the stomach, the small and large intestine, etc. Those are all the alimentary canal, or basically the gastrointestinal tract. On the other hand, anything that is not part of it are accessory organs: the liver, the gallbladder, the pancreas, salivary glands, things like that are all accessory structures. But all the other parts of it, and you have to know, and you have to and be aware of all the different portions of it, the three parts of the small intestine with regard to, so you have the duodenum, the jejunum, the ileum, the cecum, which is the first component of the large intestine, the ascending, the transverse, the descending colon, the sigmoid colon, the rectum, etc. All of those are still parts of the alimentary canal, what we call the gastrointestinal tract. And remember the motion that occurs. We have a combination of peristalsis, okay, and we have segmentation. Those two movements, even though they're more physiological, but they're really related to the anatomy, and it has to do with that external layer of muscles. Again, the deeper layer is consistently circular, and the superficial layer is consistently longitudinal. And that basically is that squeeze and push, squeeze and push. And the backward and forward is it's somewhat of an alteration. We see that mostly the segmentation, particularly as you get into the small and large intestines. So that's an important component to remember, as well as particularly the definition of the alimentary canal. The nerve supply is very, very straightforward. It's basically the vagus. Okay, that is we're, we will look at this next term when we start to look at the autonomic nervous system. But you have basically two kinds of controls: sympathetic controls, which close it down basically in something called fight or flight. When we're very active, we are going to do a workout in the gym, or you're playing a sport. On the other hand, most of the time, we call it the rest division. It's called parasympathetic, and the principal nerve is the vagus nerve. We will deal with it when we get into really the autonomic nervous system and neurophysiology in depth, and that's relatively early in the physiology term. Certainly, by far and away, first half. So when you're looking at the specific structures, you want to take it down from that. The mouth, there's not a whole lot to say. I don't do teeth. There's certainly the tongue is part of it for shaping and holding the food, and assisting with the process of swallowing. That's there. I'm not worried about the palatine arches and stuff like that. And the three sets of glands, the parotid, the submandibular, and the sublingual, are all a, really a portion. They're the accessory structures. The parotid and the sublingual are principally serous secretions. Bigger part of the parotid and the submandibular are consistently serous secretions, more moistening, and the sublingual is very, very much more mucus, more lubricating, even though they're certainly both mixtures. Again, the vast majority are serous and parotid and submandibular. And just to be clear, again, sublingual is mostly mucus. So you should remember that as well. And the unique thing about that is we begin to see these different structures. So as we carry on to the esophagus, again, we have the pharynx, the naso, and the oral, and really the laryngopharynx. But the pharynx is a shared system. But what we get into that once we get the divide at the epiglottis and start of the esophagus is mostly skeletal muscle. It's voluntary control for the first 2/3, and it transitions in the lower 1/3 to smooth muscle, and effectively that's the start of peristaltic action. Roughly 2/3 to 1/3, or the lower half. I mean, it varies individuals. And again, the hallmark epithelia still there because you effectively you have not really gotten to where we're starting to deal with a lot of the digestive and absorptive functions, really a conveyance tube, and the food is really in its roughened state, so to speak, is stratified squamous non-keratinizing. And that resumes again, stomach starts abruptly. You might remember saying that the hallmark epithelia there is simple columnar with goblet cells. And in a lot of areas, microvilli to increase surface area, particularly in the small intestine. And then when you finally get the transition from sigmoid colon to rectum, we once again make begin to switch over and make the switch back to stratified squamous non-keratinizing, because now effectively we need protection because the mass of fecal material, feces, has formed, and that requires multiple layers in a protective nature. So that's really, so it's a quick primer. Stomach, small intestine, and large intestine are all simple columnar with goblet cells, and particularly in the small intestine, and to a lesser extent in the large intestine, you have an abundance of microvilli, all those extraordinarily important changes, and I'll review them when we get to that portion here in the exam. Just sort of, again, looking at sort of narrating as things come to my head. That's there. So do remember all of those things. Remember the uniqueness of the arrangement of the peritoneum. We have something called mesentery, and mesentery is like a double layer fold of what's called visceral peritoneum. So rather than being something just like typically like we have the epicardium on the heart, or the epi, the the epipleural layer. We have the parietal and visceral pleura, the parietal and visceral uh, epicardium. It's a little bit different. When we begin to look at those types of things, or the parietal and visceral, rather, pericardium, those are really comparatively simple layers. Here, it's a bit more complicated. I'm going to be angry at the dog if you have to take me out in the snow. The mesenteries are a double layer fold of peritoneum, and they encase blood vessels and lymphatics and nerve supply, and they're really uniquely arranged, and that's what maintains as I commented to you, maintains those organs, the folds, the arrangement, the packing of the small intestine, the surround of the large intestine, and it allows them to be constantly mobile, other than those areas where it's retroperitoneal, and that would start with the duodenum. The duodenum is that little sort of C-shaped area at the exit point of the stomach. That, and I say it's tacked down. It's typically tacked down for stabilization. Duodenum, particularly because of the common bile duct, now we call it the hepatopancreatic ampulla. So that's an important area. I'm going to be angry at the dog if he continues to do this. Okay. Oh, another thing about all those cells, the cells are very, very actively mitotic. They're the most actively mitotic cells. I'm not talking about the simple squamous. I'm talking about the simple columnar with goblet cells. We replace them all every 3 to 6 days, and in the small intestine faster than anywhere else. That's particularly in those intestinal crypts. And we'll talk about that a little bit more in physiology that are there. So all of that's important. The layering of the muscularis externa is important. All of those 4 layers. You really have to know that arrangement that's consistently through the stomach, small and large intestine that are there. It's really an important thing to be noteworthy. And they start, remember, you have the mucosa itself with a simple columnar with goblet cells. Then you have a submucosal layer that supports it. Remember, they're coming through there is a tremendous amount of absorptive material. There's a lot of secretions coming out of that area. Remember, in the stomach, you have the glandular structures and then And the small intestine, you have the crypts. We didn't go into them in quite a significant data. I think it's a little more important in the stomach because really those gastric glandular structures with a different cellular arrangement is really important. I'll get back to that as I'm beginning to sort of narrate through this. Then you have that interesting layer, the muscularis mucosa, that sort of basically, given with stretch receptors, it's able to literally, once the stretch receptors are triggered, it contracts and basically adapts itself for maximum contact to the food that's there. Very interesting. And then all of that, because that's such a busy area, it has its own submucosa dedicated to that, blood vessels, lymphatics. Remember, it has its own nervous system. So you have a layer in the submucosa nervous system. You have a layer just on the exterior portion of the muscularis externa, the circular and muscular layers. Very, very complex, and we call it the gut brain. It really controls itself. Everything else, the dog is not going to let me go. The largest salivary gland is the parotid. You need to remember that. Okay. Vis-a-vis the blood supply, the stomach, the spleen, and the liver are all supplied by the celiac artery. So the celiac artery is the first artery of significance with regard to supplying the stomach. Then you have the superior and inferior mesenteric. Superior mesenteric involves some stomach supply, but also is mostly small intestine, where the inferior mesenteric is typically mostly large intestine, but also branches off for some of the latter portions of the small intestine. Remember anatomically where the esophagus enters the stomach, that sharp juncture point, because there's a stricture that occurs there. Not a stricture, there's effectively a valve, and that's just a narrowing and thickening of muscle that acts as a valve. And that's called the cardiac sphincter because there's proximity to the heart. Okay, and remember the regions of the stomach. You have the cardia in that area where the esophagus enters, the dome-shaped portion, which is the fundus. You're going to see a fundus in the uterus, and dome-shaped areas are shaped like that. This one, because of it's basically the undersurface of the diaphragm, which is dome-shaped in any event. And then you begin to see, and then it goes into the body with a rugae when it's empty, and as it stretches, obviously this rugae will disappear, but effectively as it's filled and not filled to completion, there's those rugae or ridges that allow the muscular action, because really it's a mechanical digestive area with some chemicals added for good measure, particularly the acidity and the start of protein digestion with the pepsin. And remember, there's a deep oblique layer in the stomach that basically shuffles the food forward and back. Then, as it begins to work its way, it begins to narrow toward the pyloric area and starts with an entry point called the antrum, and then narrows until there's another sphincter called the pyloric sphincter, and that controls the flow into the first loop of the small intestine, or the first section of the small intestine, which is the duodenum or duodenum. Again, that's small, 10, 12 inches, surrounds the head of the pancreas. Site of that important hepatopancreatic ampulla or common bile duct, where the secretions from the liver and the pancreas enter, which are the pivotal point, as I made it a very elaborate point because of all the stuff that's happened to me. And then we carry it on into the longer portions, about 8 feet of jejunum and about 12 feet of ileum. Remember, it's ILEUM, not like the bone ILIUM. Okay. And that area where the cardiac sphincter enters is called the esophagus. By definition, that opening in the diaphragm is called the esophageal hiatus, and that's where we see a hiatal hernia. That's when some of the stomach outpouches, sort of like a bubble in a tire, because the valve has some degree of incompetence. Mostly happens when folks get older, and it has a lot to do with, and you can deal with it with diet and things like that. It's typically not something you want to approach surgically, but it happens. It happens in babies too. Then it's inherently a fault with regard to that. So that's really an important area that's there. Remember, there's 3 openings in the diaphragm. Just for general knowledge, I'm not a question that's going to happen here. One is the esophageal hiatus. The other 2 are for, obviously, the abdominal aorta and the inferior vena cava. Okay. And so the big deal with the stomach, the body of the stomach, that's the mixing bag. I can't stress that enough. What filters into it, the secretions from those glands, that's where hydrochloric acid comes from, the parietal cells. That's where intrinsic factor to assist with basically vitamin B12 absorption. They come from the parietal cells. The chief cells make the precursor pepsin, ogen. Remember, because they're proteolytic enzymes, we don't want to auto digest if they get loose, because they'll attack any protein. And so pepsinogen is inactive, and as it makes its way into the stomach in that acidic environment, it's activated into pepsin. That starts protein digestion. At the same time, it's somewhat of a positive feedback loop where pepsin begins to reinforce that development. So it's really nicely constructed to make sure that the acidity plays an important role and really increases the activity of the protein digestion by sort of reinforcing it with that positive feedback loop. And magically, as it gets into the small intestine, which is an alkaline environment, it ceases. Again, this digestion, as you'll get to in physiology, is pH control. Thank you very much to my dog, who's very interested in people shoveling. Don't forget the roux guy in the stomach. Thank you. I've covered that. So, wait, I've got it. Thank you. I'm getting here. Hey. Whoa. Lincoln, settle down. I have to change the question here, but I'll get to it. Sorry for all that interruption. And don't forget the names of those Peyer's patches. They're part of the lymphatic structures. Lincoln, please stop. Thank you. And I'll carry on in a second as soon as he settles down. I'll come back. Sorry for the interruption, but he's a dog. Stop it.